Okay, so I'm gonna share my screen. I'm gonna log into Schoology. So I've already posted this I already posted this in the folder from last week, but I also posted it in the folder for this week as well. So you guys can read over the project and the requirements. So click on the folder for this week, the week of September 28th to October 2nd. You guys will see instructions here for your motion project. And guys, this project is something that everyone in the physics department is doing. So all the physics teachers are assigning this project. This is something that is required of us by the district. The district required this year that every core teacher do some sort of performance assessment every 6 weeks. Now, before I begin describing this project, I want to say something here. If you guys notice, the project due date is officially October 2nd, which is this Friday. So that's the official due date. However, I personally will be accepting the project up until Sunday night at midnight, okay, in order to get full credit. And my reason for doing that is because I understand you guys are very busy with all of your classes. I get it. Y'all have 8 classes. There's a lot going on right now. And, y'all have a lot of work throughout the week. So, if you guys want to spend the weekend working on the project because you have so much to do during the week, I'm allowing you guys to do that. So it is officially due Friday, and you can still turn it in Friday if you want to. Just know that me personally, I will be accepting the project up until midnight. Okay, up until midnight Sunday. Everybody got that? So just keep that in mind. Now, here's what you guys have to do for this project. So, basically, you have to describe some sort of narrative or short story that includes all of these vocabulary terms that we've talked about in class so far: distance, time, speed, velocity, direction, acceleration. You have to use all of these terms in your short story, and you must describe 4 locations in your narrative. Now, guys, you are allowed to work by yourselves, or you can work in pairs. If you work in pairs, it must be with the student from this class. Okay. Now, let me give you guys an example of a short story or a narrative that you may want to do for your project. You can talk about a camping trip, a vacation. You can talk about a scavenger hunt. Be creative. It can be any narrative that you want. So, to give a specific example, let us imagine that every summer you decide to take a trip to Colorado. Okay, I actually knew a family that did this once. They went to Colorado every summer. So, what you would do for your project, you would document that narrative, um, and you basically create a poster board, and you must discuss specifically 4 locations. So, for example, you can say that on the first day, we spend time traveling from Dallas, Texas to Ouray, Colorado, and of course, you have to use physics terms. You have to say, okay, since the distance is 929 miles and we're roughly traveling at 65 miles per hour, it should take us on average about 14 hours or 15 hours to get to Colorado. So, be descriptive in your project. And again, you have to talk about at least 4 locations. So, after you arrive at Colorado, you can say, okay, well, we're going to spend a day visiting the Rocky Mountains. How long does it take to get to the Rocky Mountains? What are the directions to get there? And then the third day, you can say, okay, after the Rocky Mountains, we visit the Great Sand Dunes in Colorado. And then after that, we spent the 4th day returning back home. And here was our trip. Here were the stops that we made along the way. So it must be a project on a poster that's descriptive of at least 4 locations, basically describing a narrative of everywhere you went and everywhere you traveled. Okay, and this is just one example that I gave. It could be a vacation. It can be, a trip to somewhere here in Texas. Basically wherever you want. Just as long as you are sticking to the directions and using these physics terms. Also, one more thing I want to say, guys, even though in the instructions it says you have to do your project on some sort of poster board, you can do that, but if you want, you can also make a PowerPoint presentation of your project as well. So you can do all your locations in a single PowerPoint and turn into me that PowerPoint presentation. I will accept that as well. So you can do a poster board or a PowerPoint. If you do a poster board, when you're done with your poster board, just be sure you're taking pictures of it and you're turning those pictures into me. Okay, or if you're doing a PowerPoint, just turn the PowerPoint into me. It is completely your choice. Okay, and of course, at the bottom of the project, they have another example here. For example, here's an example of a scavenger hunt. This is a scavenger hunt or a treasure hunt for how to find. This is a treasure hunt for this guy named Juan. For him to be able to find his birthday gifts and all the locations he would travel to find his birthday gifts. As you can see, here's the narrative off to the side. Here they have science calculations, distance, speed, velocity, things like that. So guys, be descriptive as much as possible. Okay, and of course, here's at the bottom, there's a rubric of everything you're going to be graded on. So that's pretty much the project. In a nutshell, you're just describing a basic narrative that includes at least 4 locations, and it must include all of these terms that we've discussed in class. Be sure you underline these terms wherever they appear in your project, because I'm going to be looking for them as I go through and grade the project. Any questions on the project? Okay. Anyone? The instructions are currently uploaded in Schoology. If you guys do have any questions while you guys are working on this, please don't hesitate to reach out to me. Again, even though it is due this Friday officially, I will be accepting it up until Sunday night at midnight. Again, like I said, I realize you guys are very busy, so if you need to take the time this weekend and work on that, that's great. Oh, and one more thing I'm going to say, I won't assign any work to you guys on Friday. Like on Friday, like normally I might assign an exit ticket or something for you guys to do. I will not assign any work for you guys on Friday. Friday is just the time for you to work on your project. No assignments this Friday. Okay, that is time for you. Again, this Friday, this weekend, you have that time to work on your project. All right, let's move right along. So today, I want to focus on distance and displacement. So let me put up the PowerPoint. Okay, so again, we're going to focus on distance and displacements, and then by the time we're toward the end of this Zoom call, we are going to discuss graphical analysis of motion, and then I'm going to tell you guys what you need to do for your assignment for tonight, which is just basically to watch an Ed Puzzle video. So it's not that bad. Okay, so looking at this PowerPoint here. So these 2 terms are something that you have heard me mention before in this class, distance and displacement. And this is something you guys have probably used in your everyday life. However, when we use these terms in our everyday life, we tend to use these terms interchangeably. However, there is a slight difference in meaning between the two. Okay. So distance is defined as the total ground an object covers over the course of its entire trip. Displacement refers to how far out of place an object is from its starting point. Displacement also includes the object's direction relative to its starting point, or relative to its starting position. So in order for you guys to understand that, let me just give an example of what I mean. So imagine that I have this grid here, and imagine that I'm walking along this grid. Okay. So guys, pretend that I start here. So this is my starting point. So I'm standing on this grid, and that's my starting point. Okay. Now imagine that while I'm on this grid, I decide to walk 6 meters toward the east. So 6 meters in this direction. So toward the east. And I come to a stop here. Okay. So I come to a stop here. And then after I come to a stop, I decide that I want to walk 2 meters toward the west. Okay. So, and I decide I want to stop here. Okay. Now, guys, if the dot in red represents my starting point and the dot in blue represents my ending point, someone tell me, what was my overall distance covered during the course of this trip? Anyone? I went 4 meters to the east, and then I walked 2 meters back toward the west, and I stopped. What was the total ground that I covered? So guys, the total ground that I covered was 6 meters. Okay, so therefore that's my distance. My distance is 6 meters. However, what is my displacement? Remember what displacement is. Displacement is how far I'm out of place from my starting point. Well, my displacement here is 4 meters toward the east, because that's how far I'm displaced from my starting point. And of course, I'm 4 meters to the east of my starting point. Does that make sense? So everybody can see the difference between distance and displacement. So my distance is 6 meters, and my displacement is 4 meters. Let us look at another example. Okay. Suppose that I decide to start right here while on this grid. And let us assume that I walk 4 meters south. Okay. And then after that, I then walk 1 meter north. So and of course, I decide that I want to stop here. Okay. So the dot in green represents my starting point, and the dot in blue represents my ending point. Okay. Someone tell me, what was my overall distance covered during the course of this trip? I walked 4 meters south and I walked 1 meter. I'm sorry, I walked 4 meters south and I walked 1 meter up north. What was my distance covered? The distance here that I covered was distance that I covered here was 5 meters. No, it was, I had it right at first, it was 4 meters. I'm sorry, I looked at that line. My distance covered was, no, wait a minute. Yeah, my distance covered was 5 meters. I'm looking at this on this grid wrong. My displacement was equal to 3 meters south. 3 meters south was my displacement. And again, because this final dot here this final dot here is 3 meters south of my initial point. So everybody understand that? Displacement refers to the total ground an object covers. I'm sorry, distance refers to the total ground an object covers. Displacement refers to how far out of place an object is relative to its starting point. All right? Now, with that said, I want to do this distance versus displacement assignment with you guys. Let me pull it up. Let's see. So this PDF file that I'm about to pull up that we are about to work together. It is currently in Schoology for you guys to access. Give me just a second. Let me try to pull up both files in the browser, and then in just a moment I'm going to share my screen. Okay, now this worksheet, typically in the past, what I would do, I would assign this worksheet to my students in class, and we will work on it together. But of course, obviously, since we are working virtually, you guys have no way. I have no way to distribute a paper copy to you all for you guys to fill in. So we're just going to kind of talk through this together. And I want you guys to follow along, because if you guys see questions on the tests for next week involving distance and displacement, I want you guys to understand how to do those questions and how to do those calculations. So follow along with me. Okay, so okay, so here gives you the directions of what to do. So here are the directions of everything we're going to do on this worksheet to best understand the difference between distance and displacement and how to do several calculations. And we're going to actually do our work on this file here. Okay, so real briefly, so let's just read step 1 here. Okay, so step 1 here says measure a distance of 10 centimeters straight east and mark it as point A. Write down the distance for leg 1 and measure and write down the displacement. Okay, so what they're saying here is that right here where this says home here, this is considered to be our starting point on our grid. So we're going to walk 10 meters straight east, because that's what the direction said. Walk 10 meters straight east. Okay, and then once we do our measurements, we're going to write everything here. Okay, we're going to fill this in for basically leg 1, leg 2, leg 3, and leg 4. All right, so starting here, okay, we want to go 10 centimeters straight east. So if we're going to go 10 centimeters straight east, and each square represents half a centimeter, that means in order to go 10 centimeters straight east, we need to go at least 20 squares in this direction. So I'm going to draw a line covering 20 squares. So starting here, this is our starting point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so let me count that again, make sure it's 21. Okay, so that's 20 squares, and we're going to label this point right here. So well, let me use a different color. So this point right here, we're going to call that point A. And we're going to label this leg 1. Okay. Now, for leg 1, okay, this should be pretty simple as far as filling out, the distance and the displacement. Okay, so let me zoom in here so you guys can see this. Okay, so leg 1 has a distance or a length of 10 centimeters. So we're going to fill this in, 10 centimeters. And what was our total distance that we traveled as we walked from here to here? Well, that should be pretty obvious. We went a total of 10 centimeters. And what was our overall displacement? Now, guys, remember, displacement includes direction. So our displacement was 10 centimeters toward the east. Okay. So whenever you're filling out displacement, be sure you are including your direction as well. Okay. So, all right, I'm going to speed this up because I want to get done with the next 4 or the next 3 items pretty quickly. So it says, step 2 says, measure a distance of 10 centimeters straight north and mark it as point B. Write down the distance for leg 2. Write down the total distance traveled from home and use the ruler and protractor to measure and write down the displacement. Okay, we're not going to necessarily need a protractor, but I'm going to show you guys how to calculate displacement. Okay, so step 2 says to draw a line that is 10 centimeters straight north. So what that means is that from this point right here, I need to count 20 blocks upward, since each block is half a centimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, and then 16, 17, 18, 19, 20. Okay, so then I'm going to stop there. And I'm going to label this point right here. I'm going to label that point, point B. Okay, and of course I'm going to call this leg 2. Okay, now, with that said, what is the distance for leg 2? It is 10 centimeters. Now, someone tell me, what is the total distance that we covered since we left home? Remember, we started here, then we walked here, and then we walked here. So what is the total ground that we covered? Anybody want to put the answer in the chat box? If you don't want to speak it out. So what is the total distance that we've covered here? So the total distance that we've covered here is 20 centimeters. Okay, but what is our displacement? What is our displacement? Remember, displacement represents how far out of place we are from our starting point. In other words, it's the shortest distance between 2 points. So when I talk about displacement, I'm basically talking about the distance from here to here. Okay. So what is our displacement up into point from the starting point to point B? Okay. Does anybody remember here how to find this distance here? The length of this side here?
It's the square root of x2 minus x1 squared
Exactly.
minus y2 minus y1 squared.
Exactly, Sky. So in other words, you're going to use Pythagorean's theorem, right? Is it exactly? So so remember what x is. X and y are both 10 centimeters. Thank you. You're the first student this week to get that so quickly. Uh, but yeah, you're right. This length here is 10 centimeters, and this length here is 10 centimeters. So in order to find this length here and this side here, I'm going to label this C. We have to use Pythagorean's theorem, which is a squared plus b squared equals c squared. And so you're right. X squared plus y squared. X is a and then y is b. And of course, this is just 200 is equal to c squared. Now, the question is, how do I get rid of this squared, guys? Mathematically, what's the opposite of squaring something? How do I get rid of that squared, guys?
Square rooting.
Yep, take the square root. So the square root of 200 gives me my answer. Okay, so with that said, that means the total displacement from this point to this point is the square root of 200. And if you guys put that in your calculator, that gives you 14.14 for your displacement. So so it's 14.14 for our displacement. And we're displaced toward the northeast. Okay. All right, so we're almost done here. That was probably the most complicated part of this worksheet. Okay, so let's keep going. So we're at step 3 now. It says measure a distance of 10 centimeters straight west and mark it as point C. So we're going to write down the distance for leg 3, write down the total distance traveled from home, and then we're going to figure out what the displacement is. Okay. By now, hopefully you guys are seeing the basic pattern. Okay, so remember, we want to go 10 centimeters toward the west. That's what step 3 said. So 10 centimeters toward the west. So that's 10 meters toward the west. And we're going to label this. And we're going to label this point B. I'm sorry, we're going to label that point C. And this is considered to be leg 3. Okay. Now, someone tell me. Okay, well, hold on. Let me not get too far ahead of myself. If we know the distance of leg 3 is 10 centimeters, because that's the length of that leg by itself, is 10 centimeters. Someone tell me, what is the total distance or the total ground that we've covered since we started walking from our initial point here? So if we went 10 centimeters in this direction, 10 centimeters in this direction, and 10 centimeters in this direction, what is our total distance covered? What is the total ground that we've covered, everyone? It is obviously 30 centimeters. Okay. As far as the displacement, the question is, how far are we out of place from our starting point? Remember, this was our starting point, and now we're here. So what is our displacement? Well, that's easy. Our displacement is just 10 centimeters toward the north. Remember, displacement includes direction. So how far you are out of place relative to your starting point is the definition of displacement. So we are displaced 10 centimeters to the north. Okay. And the last step for this worksheet here says measure a distance of 10 centimeters straight south. Write down the distance for leg 4, write down the total distance traveled from home, and then measure and write down the displacement. Okay, so now the last step, starting at this point right here, we want to go 10 centimeters straight south. Okay, and so we're going to label this leg 4. Okay. Now, the length of leg 4 is 10 centimeters. What was the total distance that we covered throughout the course of this entire trip? Guys, this should be obvious. If we started here and we went 10 centimeters in this direction, 10 centimeters in that direction, 10 centimeters in that direction, then 10 centimeters in that direction, we covered a total of 40 centimeters. So 40 centimeters was the total ground covered. Okay. However, what was our displacement? And guys, this should be super easy. We came back to our starting point. So if we came back to our starting point, our displacement is just what here? Our displacement is just 0 because we came back to our starting point. So our displacement is 0. All right. So if you guys see distance and displacement on the tests for next week, do you guys think you'll be good as far as understanding how to work out the calculations mathematically? Any questions? Let me stop my screen. All right. We have about 9 more minutes. So I want to spend the end of the class talking about graphical analysis. And the reason why is because this afternoon you're going to have an assignment to do. Let me share my screen so you guys can see. Okay, give me just a second. Let me close out these tabs. Okay, so as soon as this class is over, I am going to make this Edpuzzle assignment available to you guys. Guys, there is an Edpuzzle video in Schoology that you guys have to watch. Remember what Edpuzzle is. Edpuzzle allows me to post videos from YouTube, and I can basically embed them into Schoology, and then I can add questions in the video. The video is about 8 minutes long. It's not that long at all. All you have to do for this afternoon is watch the video and answer the questions that are embedded in the video. And then that's going to be your grade. As soon as you get done, your grade should pop up because they're all multiple choice questions. Okay. So basically, the Edpuzzle video will cover position versus time graphs. Now, since we're about to start talking about graphs, I want to say something here. It's very important that you guys remember how to calculate slopes of lines on a graph, because that's going to be important for our next topic. when we get to position time graphs. If you guys remember from algebra, from your algebra class, remember what is the definition of slope? The definition of slope is rise over run. In other words, y2 minus y1 divided by x2 minus x1. Now, for example, look at this line here. Okay. If I wanted to take this, if I want to take the slope of this line, the simplest way to do that is to count from this end right here, from this end of the square to that end of the square. That's the simplest way to find the slope. By the way, does anybody want to tell me what do you guys see here? Do you see a negative slope or a positive slope here?
Negative.
It's a negative slope, exactly. So if it's going downhill, it's negative. If it's going uphill, it appears to be positive. If it appears to go uphill, then it's a positive slope. Because remember, you read your graph from left to right. Okay, so with that said, guys, in order to calculate this slope here, all you will need to do is just do basically rise here over run. Remember, we're counting from this endpoint to that endpoint. This endpoint of the square to that endpoint of the square. So we went 2 meters up, and of course we went 3 meters in the negative direction. So that's what gives us a negative slope. So our slope here is negative 2 over 3. Okay. Let us do another example. What about the slope here? So this slope here is obviously positive. So in order to figure out this slope, again, I want to count from this endpoint of this square to that endpoint of that square. So remember, whenever you're finding slope, and again, this is something that you guys should have talked about in algebra, so hopefully you guys remember this. So it's just rise divided by run. Okay. So how many squares did I rise? It went 1, 2, 3, 4, 5, 6. So I went 6 squares in the positive direction. That's my rise. Divided by my run, which is 1, 2, 3, 4. Okay. So that's 6 divided by 4, which reduces to 3 over 2, which reduces to, what time is it? I got time. Which reduces to 1.5. Okay, so that is my slope. So whenever you guys are watching that video today, they're going to apply graphs to physics, specifically position time graphs, and some of those questions will involve finding the slopes of the lines on those graphs. Okay, so just keep it in mind whenever you guys are working out the assignment for later on today. If there are no questions, no immediate questions at the moment, you guys are free to go. Let me know if you guys have any questions for this afternoon while you guys are working on your assignment. And I hope you guys have a good one, and I will see you all on Thursday.